Hey guys, welcome back. In the last lesson, we started 3 EC2 instances in AWS, and we also connected to all 3 instances. In this lesson, we'll install all the needed components and configure all the required Hadoop components to start a Hadoop cluster. Now, the next thing we need is the latest Java development kit from the Oracle website. So let's Google for download Java. And let's click on Java SE downloads on the Oracle website. Now here click on JDK download. Now first accept the license. Now click on this JDK file with .gz extension for Linux 64. Click on it. And this will start the download. So let's wait for the download to complete. And let's copy this file to our master node. The download is now complete. And here's the file. This is the latest JDK 1.8 release 6.0 for Linux, and it is gzip compressed. Let's now copy this downloaded JDK from our Windows laptop to the master instance. You can do that with few different ways. Here I'll be using a small software called WinSCP to copy a file from Windows to our master instance. So click on New and copy the public DNS for the master. Paste it here. For the username, give Ubuntu and select the private key file. The private key file that we have to select here is the .ppk file which we generated from the last lesson using the PuTTY-gen. So select that and hit save and give a name to this. I'm going to name it as master. So click OK. So now click on login. Say yes. Now we are connected to the master instance. On the left hand side you see here is the contents of our Windows machine. And the right hand side, you will see the contents of the master node. So you can pick any file from the left hand side and drag it over and drop it on the right hand side, which will copy the file from Windows to the connected Linux instance. So let's drag and drop the JDK file from Windows to Linux. Now we have to wait for this copy to complete. Once we have the file on the master node, we'll use scp command on Linux to copy between master to slave 1 and master to slave 2, which is much faster than using WinSCP. The JDK file is now copied. We can now see the JDK file on the right hand side, which is our master instance. Let's also do an ls on our master instance here, just to be sure. There you go, we see the JDK file. Now let's use the scp command to copy this JDK file from our master to slave 1. Type in S. And there you go, the file is now copied and it is super fast, isn't it? So let's do the same for slave 2 as well, from the master node. Say yes. And there you go, the JDK file is now copied to both slave 1 and slave 2. Let's just make sure. ls, there you go, I see the file on slave 1. Again ls, there you go, I see it on slave 2 as well. Now here's what we will do. We'll use the tar command to unzip the file and move the uncompressed JDK files to user libjvm. Let's go ahead and do that on all the nodes. First, we'll do an unzip using the tar command. We'll do it on the master first. Our JDK is now uncompressed in master. Let's do it on slave 1 and also on slave 2. Slave 1 is done. Slave 2 now. Slave 2 is done as well. So now let's create a directory named user libjvm and let's move the JDK contents that we just uncompressed to user libjvm. So let's make a directory first. Let's do it on the master. Let's do it on slave 1 and let's do it on slave 2. Now let's move the JDK folder under user libjvm. Master, slave 1 and slave 2. Next we'll do 3 things. First, we'll use the update alternatives command to point all the Java executables under user bin to point to the new JDK which we just uncompressed. Second, we'll set proper permissions for the Java executables. Third, we will set the Java underscore home environment variable to point to a new JDK. Let's go ahead and run the commands on all three nodes. So let's first run the update alternatives command on all three instances. Let's run on the master first. There you go, it's done. Let's run on the slaves now. Okay, that is now done. So let's clear the screen just for easy readability. Let's now set the permissions on the Java executables. Done on the master. Clear the screen. Run on slave 1. Clear the screen on slave 2 and run the same set of commands on slave 2. Now let's set the Java underscore home environment variable in the environment file under etc directory. So let's open the file first. Go to the insert mode, append to the file. And let's set the Java underscore home variable to the new JDK path using export. Save the file on the master and do the same operation on slave 1 and slave 2. There you go. Now the environment variable Java underscore home is set on all three instances. Now we have properly set up JDK on all the nodes. Now we are ready to download and install all the needed Hadoop components from Cloudera. Our operating system should know where it can download the Hadoop distribution from. So we need to add these two lines to cloudera.list file under sources.list.d directory. So when we execute commands to download Hadoop components, so the operating system knows it can go to the HTTP location mentioned on these two lines to download the needed files. The next step is important. We need to update cloudera.pref file under preferences.d directory with the lines that is shown on the file here. We are doing this to avoid potential library conflicts. We are saying when the libraries we are trying to download are found in Cloudera and also in other already configured location, give preference to the Cloudera's website, so that we don't end up with a portion of libraries from Cloudera and a portion of libraries from some other website, which will lead to library conflict issues, and we don't want that. So let's update the cloudera.list file and cloudera.pref file on all three nodes. So let's go to the master, open the Cloudera list file, switch to insert mode, copy these two lines here and paste it. Now let's save the file. Let's now open the Cloudera pref file, switch to insert mode, copy the three lines here, paste it and save it. Let's do the same on slave 1 and slave 2. Now we have updated the cloudera.list file and cloudera.pref file. We are now ready to download and install all the Hadoop related components. The first apt get update command will download and updates all the packages from configured repositories, which means it will update and download all the libraries from Cloudera repository as well. Next, we will install specific components on specific nodes. On the master, we'll install Resource Manager, Name Node, History Server, Proxy Server, and Hadoop Client. We know what a Resource Manager and Name Node is. History Server will hold a history of all the application executions, like MapReduce jobs, big executions, Hive executions, etc. Proxy Server act as a proxy to the yarn, and this is needed to reduce the possibility of web-based attacks through yarn. Hadoop Client has all the needed libraries to execute all Hadoop-related client commands, like HDFS commands, yarn commands, etc. On Slave 1 and Slave 2, we'll install Node Manager, Data Node, MapReduce, and Hadoop Client. On Slave 1, we will install one additional component, which is the secondary name node. Now let's install the specific components on each node by running these commands. So let's do an apt get update on all the nodes first. So let's do it on the master. Now the packages are being updated. This error is trivial, so ignore that. So let's do the update on Slave 1. And let's do the update on Slave 2 as well. Now let's clear the screen on the master. Go back to our file. Let's install the Resource Manager first on the master. Hit yes. Yes again. Now this is going to download and install the Resource Manager on our master instance. As you can see, this is installing all the needed libraries to run a Resource Manager. The Resource Manager is now installed. Let's move on to install the name node. Yes. The name node is now installed, and the installation also attempted to start the name node. Since we haven't configured our Hadoop cluster yet, the name node failed to restart. But don't worry about this failure at this point, because once we configure the Hadoop cluster properly, there should not be any errors. So let's move on to the next installation. Here we are going to install the History Server and Yarn Proxy Server. So let's clear the screen. Go for yes. History and proxy servers are now installed. Again, there is a failure when it tried to start the proxy server. Don't worry about it for now. Let's move on to install Hadoop Client. Hadoop Client is now installed on the master. Now we have installed all the needed components on the master. Let's move on to Slave 1. We have already executed the update commands on both the slaves, so let's go ahead and install the secondary name node on Slave 1. The secondary name node is now installed. Let's move on to install the Node Manager, Data Node, and the MapReduce libraries. Yes. Node managers and data nodes are now installed. Let's move on to install the Hadoop client. The installation on slave 1 is now complete. Now let's go ahead and do the same for slave 2. Let's clear the screen on slave 2. Here we're going to install Node Manager, Data Node, and MapReduce. Yes and yes. The Node Manager and the Data Node installation is now complete. Let's go ahead and install Hadoop client. The installation of Hadoop client is completed on slave 2. Now we have all the needed components installed on all 3 instances. It is now time for configuration. Let's look at each configuration file and cover the key important configuration properties on each file. We will use the configuration files under etc hadoop conf.mt as templates to create our own configuration files. So let's copy those files to etc hadoop conf.cdh5 directory and apply our changes to it. Next, we will run the update alternatives to point etc hadoop conf to the configuration files under conf.cdh5 directory, where we will update all the configuration files which are specific to our cluster. So let's run these 2 instructions just on the master. So let's clear the screen. So this command is going to copy the configuration files under conf.mt, which are pretty much templates, to a new directory named conf.cdh5 under etc hadoop. So let's go ahead and do that. Next, let's run the update alternatives command. All right. Let's look at the core site.xml file first. These 2 properties, fs.defaultfs and io.compression.codecs, are very important. Here, we'll define the file system as HDFS along with the location of the name node and list all the compression codecs that we support. So let's copy the contents from here and paste it into our core site.xml file. So let's open the file first. And as you can see, we are opening the core site.xml file from conf.cdh5 directory. So the file is pretty much empty. Now we have to copy our configuration and paste it in this file. So now copy the contents and paste it. That is it. Our core site.xml file is now ready. Let's move on to the hdfs site.xml file. In hdfs site.xml file, we'll provide the directory location for the name node and data node in the local file system using the dfs.namenode.name directory and dfs.datanode.data directory. We'll also provide the web address for the name node using the dfs.namenode.http address. So let's open the hdfs site.xml file and copy the contents from here to the file. So we already have some contents on this file, so I'm going to delete those existing contents. So the configuration is now empty. So I'm going to copy the contents from our file and paste it into hdfs site.xml file. Now our hdfs site.xml file is ready. Let's move on to the MapRed site.xml file. In the MapRed site.xml file, we'll use the MapReduce framework name to specify we will use Yarn as our MapReduce framework, as opposed to the legacy MapReduce framework in MRV1. Next, we'll provide the address of the job history server using mapreduce.jobhistory.address. So let's open MapReduce site.xml file on our master node and copy the contents from here to the file. Copy the contents and paste it in the file. Now our MapRed site.xml file is ready. Let's move on to the Yarn site.xml file. In the Yarn site.xml file, we'll provide the information about the resource manager first. the host name, web address, resource manager, scheduler address, etc. Since the resource manager is configured to run on the master node, we'll provide the master node details here. Next, we have to specify the yarn application class path with the list of all the directories which has the libraries to be included in the class path. And with the MapReduce shuffle.class property, we'll provide the class which is responsible to perform the shuffle operation. The yarn node manager local dirs specifies the location of the directory in the local file system to be used by the node manager. And finally, yarn node manager log-dirs specifies the location of the directory in the local file system where the logs for the node manager will be stored. We can also choose to enable log aggregation, and when enabled, we need to specify the location of the log directory in HDFS using yarn node manager remote app log directory property. So let's now copy this contents into the yarn site.xml file. Here you already see some predefined properties, so I'm going to delete all those. There you go. They are now deleted. So let's copy our contents and paste it into this file. The contents are now pasted. Our yarn site.xml is now ready. Finally, we have one more file to configure, and that is the masters file. The masters file will list the node on which the secondary name node is running. Since we installed secondary name node on slave 1, we'll give the address of slave 1 here. So let's open the masters file, go to the insert mode, and copy the slave 1 address into the file. Let's save the file now. All our configuration XML files are now ready and configured with our cluster details. Now we have to manually set the java_home on BigTop detect Java home under BigTop utils. The BigTop detect Java home script could not seem to find the java_home environment variable and errors out during startup. So we have to manually set the java_home environment variable in that file. So let's go ahead and do that. So we're going to open the file first. And go to this location right here just before the for loop and the if condition. And open the file on insert mode and copy this Java home environment variable export to the file. Paste it and then save the file. Now we have all the needed configuration files ready on master. Let's create the conf.cdh5 directories on slave 1 and slave 2. Set the permissions to allow write to those two directories and then copy the configuration files from master to both slave 1 and slave 2. So that way we don't have to redo the configuration files on slave 1 and slave 2. So let's do that now. So I'm going to execute these two commands on slave 1 and slave 2. Clear the screen on slave 1, copy the contents of conf.empty to conf.cdh5 and set the permission to allow write on etc Hadoop directory. There you go, that is complete. Let's do the same on slave 2. Now we're going to copy all the configuration files from the master to slave 1. Let's go to master. Now this command will copy all the configuration files to slave 1. There you go, that is done. Let's do the same for slave 2. Now that we have configured the files, let's revoke the write permissions on etc Hadoop directory. So let's copy that, execute on slave 1, and execute on slave 2. Just to make sure we have copied all the configuration files, let's open the yarn site.xml file under etc Hadoop conf.cdh5 on slave 2. vi yarn site.xml file. There you go. This is the file that we configured on master, which we just copied to slave 1 and slave 2. Perfect, we are good to go. Now we're going to set the update alternatives command to point etc Hadoop conf to etc Hadoop conf.cdh5 because conf.cdh5 has all the configuration files specific to our cluster. So let's copy these two commands and execute on all three nodes. on master, on slave 1 and slave 2. So far in this lesson, we installed all the needed Hadoop components on each instance. Also, we now have all the configuration files ready, which is needed to have an operational Hadoop cluster on all the nodes. In the next lesson, we'll finish the setup by creating the directories that we specified in the configuration files and few temp directories needed for Hadoop to work. And then we can start all the Hadoop services and validate the installation. See you in the next lesson.